Let's get started. Welcome to Launch Week. This is our first Launch Week inaugural um, edition. So, I know this is the second meeting in the series. For some of you who didn't attend the first meeting on Monday, I just wanted to recap what this series is. It may be a repeat information for some of you, but it might be good to just walk through at least at a high level. So the way we are positioning Launch Week is as an informal short presentation format series. I know Launch Weeks take different forms. Some are more formal, very um, you know full day sessions with a lot of deep dives. In our case, we wanted to go with more lightweight, like a 20-minute, 30-minute bite-sized sessions that people could easily understand and key features. And this is mostly focused on the community engagement exercise. It's not a marketing exercise, so we'll try to keep it technical and to the point on what the latest updates are from RisingWave, and we'll include a demos just to give you a familiarity about the how the feature gets used. Um, Basically, this is sort of a channel to promote interaction with the product team. So by that I mean, you can get information from us one way, through blogs, through documentation, through our videos, but we this is sort of more like a two-way communication where you can ask us questions, and if there is things that you want to have us feature in the future in the next version of launch week, this is a good opportunity for us to reach out and give us feedback. um, and as I mentioned, each session will have a QA session, QA at the end of the session. And our plan is to run it. When I had it on quarterly, but I feel like we still haven't finalized the cadence, but we're thinking, depending on the feedback we receive, it could be a monthly or a quarterly cadence. It depends on how much community engagement and what we get in response. And as I mentioned, the topics will include key features of each Rising Wave release. And as the community members, you know that we have monthly releases. So we'll try to not cover all the features because usually there's a lot of long list of features. So we'll pick 3 to 5 features that are most impactful and that are useful for the wider community, and then kind of go drill down on those. Our goal is to do a little bit of a deep dive, also look at possible use cases where the feature can be used, and then optionally, in some cases, for example, some features are quite prevalent in the industry with other industry solutions also offering similar functionality. So we want to provide comparative analysis on how Rising Web implementation is different, the pros and cons, so that you get a more in-depth view into what that particular feature, how our implementation stacks up against others. So this is sort of the format, and as this is an inaugural edition, all feedback is welcome, good, bad. Please do let us know. So for the agenda for this first week, we had 3 topics decided. We covered the time travel queries on the 14th, on Monday. Today we're going to talk about subscriptions feature, which includes subscriptions as well as subscription cursors. And then we'll end the week on Friday with a session on Python SDK, which is the new SDK we launched in 2.0 version. So let's dive into the topic today, subscriptions. So subscriptions are basically a mechanism, a pull mechanism, basically, because we have both pull and push with streaming systems where you can get data from one system to another. In Rising Wave, if you create syncs, that's sort of the push mechanism where you create a target destination system where you want your data to be pushed. But rather, in some situations, you would rather not have a push, but rather pull mechanism where you sort of track updates as they happen from Rising Wave. So subscription is basically that high-level interface, allow you to consume data at your pace, and basically this could the way it is it's a first class citizen, sort of like you create a subscription and then you set a retention period based on some table on MV, and as the updates happen upstream on in Rising Wave and tables and MVs, they get basically streamed in through subscription, and then the downstream system can consume it. So that's the basic idea behind subscriptions. As I mentioned, it's to pull data from records, like whatever change records at a discrete level for a specific table or for a specific materialized view. And the data that is available includes both the existing data at the time of subscription. Say, for example, if you created a subscription and the data already has records, those are obviously available to be consumed, as well as any incremental changes that happen after the subscription is created. So it's like a ongoing new updates are automatically streamed. Um, what subscription does is solve a basic problem that exists with stream processing systems. Typically, for example, with other systems like Flink, you require an external event store like Kafka, right, as an intermediate store. Like just as you bring in the data through a message queue on the source side, they require you to have a similar mechanism on the sync side so that all the updates that flow from a stream processing system go to a message queue, and from there you consume from a topic. Now you can still do that with Rising Wave with a sync, but in some cases the overhead of having another extra hop is bad for latency and also for bad for cost and operational overhead. And that's the core problem we're trying to solve with subscriptions, where you don't need an intermediate store. You can just pull from directly Rising Wave. And how you retrieve the data, right? Once you create a subscription, is through what we call it's a cursor mechanism similar to traditional database parlance, right? You have cursors, you create a cursor, and you fetch data using a fetch command. Similarly, for subscriptions, we have subscription cursors that you can use to retrieve the full data set or the incremental data set based on a after a specified starting point, where you can fetch one record at a time or a n number of records based on your application needs. So it's kind of the overview definition of what subscriptions mean. So how do you use this feature? So like I said, it's a in Rising Wave, it's a full-fledged feature. You have a full-fledged syntax as if you're creating a DDL statement. You have a create subscription command where you specify what the subscription is based on, what MV or a table, and then you can include a retention window of how long does this subscription needs to run, right? And then you can drop a subscription similar to like a create, and then you can alter it also. You can which allows there are a few options that you can change in terms of renaming a subscription or changing the ownership of subscription and setting the schema. These are the options that are available. Um, and then where does subscription get used? The potential use cases where subscription is valuable is, this is not a full list, but two most common use cases is alerting slash notification use cases, where you can use subscriptions. Users can uh, set up alerting rules. So basically, as changes happen due to transformation logic in Rising Wave, if there's a particular change that happens in dataset and you want to trigger downstream business logic. For example, say if you are building a fraud detection application and you notice that a certain anomaly you want to detect through transformations. Now, Rising Wave by itself is not an application. It will just generate the data or the insight, but to trigger that particular business logic to or a process to initiate, it needs a notification system, and subscription would serve that, right? You can set up a rule based on the change records that come from subscription, and then it can in real time you can power those downstream applications. The second thing is if you're building in general a event-driven architecture, like for example, if you're building a system that needs to synchronize data between different microservices, like for example, if you're using, well, all microservices require some sort of a metadata store that coordinates services between different systems, right? For things like that, you need a very performant notification system. And at the heart of that, you could store RisingWave as the metadata store, and then have microservices do the coordination using subscriptions. So that's a common pattern as well that we have seen with our customers. Now, let's move on to subscription cursors. This is the mechanism that allows users to pull the data from a subscription, right? Like you can specify a specific starting point as to how you want to consume the data from a subscription. So once a subscription cursor is created, you basically go in a loop, similar to how you would read from a traditional database result set, where you create a cursor and you read fetch rows. Similar to that, and we have adopted the same model, and you create a cursor, you open, and then you fetch data either from the starting point or from a specific point, a specified point in your cursor. And one single subscription can have multiple cursors, which can be used for different things, right? For example, if you have different applications and they have different ranges of data or intervals of data based on their business logic, you can create multiple cursors that all fetch data from a same subscription. So it's like a one-to-many model. And in terms of the syntax, it's pretty simple. We adopted the same ANSI SQL model of declare, you basically declare a cursor name and you specify what is the starting point of the cursor when you open. Is it a specific since clause? This is actually a new clause that we added in 2.0. Before that, you would read the entire data set. Now you have the flexibility to read only the incremental part. I'll cover that in a slide later. But very simple syntax that you are familiar with if you are familiar with traditional ANSI SQL cursor support. And then the second thing is the fetch. Fetch is the command that actually reads from the cursor and gets fetch. Next would basically get one record at a time. So if you are trying to browse through the records of what changes happened in your data in your RisingWave system, you would call this in a loop and try to match on each record what the change was, right? Or instead, if you want to get a bunch of records, say for example, if you're trying to batch those records by a certain amount, like say I need to read every 10 records, then you will use fetch n, and then we batch them, and then we send you on the size of the batch you specified, and then you can do the post processing logic. Like for example, in some cases, you want to get a batch of records because you want to compute some aggregate, for example, as opposed to a discrete value, right? In that sense, in that case, you will use a fetchn as the command. So this is the part that I wanted to address in terms of the changes that have gone in, because subscription as a feature has been there in product for a while. I think we introduced it in 1.9 as a full-fledged GA feature, and cursors came into picture at that time. But in 2.0, which is the most recent release, we made some changes. Earlier subscriptions by default would include all of the historical data that was there um, in table or MV from where the subscription was created. With 2.0, we changed the default behavior to only return the incremental data that was generated after the subscription cursor was created, right? For example, once you declare the cursor, so you would only be able to read um, from the point it was created. Now, to go back to the previous behavior where you wanted to include the historical data, you would have to add this new clause called since begin at the end of the declared statement, and then it will bring in all of the historical data. So this is a slight change to provide flexibility for the user. So because in most cases you care more about the new data coming in as opposed to historical data. That's why we made this the default mode. And the second thing is also we improved the readability of the output coming from the cursor. Earlier we were sending in the when you call fetch, we would just send you numeric values about what the changes were. Like was it an insert operation, update operation, or is it a delete operation, or is it an in update delete? Like if you have a transformation that involves both. Now we are making it more descriptive so that when you get the, after you reading the cursor, when you try to look at the changes that happened, they'll be more descriptive as opposed to just numbers. So these are the changes we have made to make it more developer friendly in the latest release. So this is sort of the overview of both the features. Now I want to play the demo video of how to create a subscription and how a subscription cursor works. So it'll be a short recorded demo we did. And then after that, I'll take some questions. Let me play the video. Subscriptions and cursors for subscriptions are relatively new features in RisingWave, previously introduced in version 1.9. With this version 1.2.0 update, a few major changes have been introduced to make the feature more user-friendly. So let's walk through how to create and use subscriptions and subscription cursors in RisingWave. To see subscription in action, we'll first need to create a table or a materialized view. For this demo, we'll create a table called test with 3 columns and insert some data into it. Once the table is created, we can create a subscription using create subscription command. The retention parameter determines how long the incremental data will be retained. Here we've used retention interval of 10 minutes. After the subscription is created, we'll declare a cursor for it. Prior to version 2.0, a cursor by default will include both the historical data up to the time of the declaration and the incremental data after declaration. But now the cursor will just include the incremental data after the declaration. So when we first fetch from the cursor, no updates are returned since changes to the tables were made before the declaration. You can change this by adding a since begin clause at the end of the statement, or you can simply specify a Unix timestamp in milliseconds so the cursor returns the data from the starting of the time period. In this case, we want to make sure that the timestamp is within the retention period. Now we can insert some values into the table and fetch the cursor again to see the incremental updates by using fetch next command. Since we added just one row to the data, the op row will tell us that insert operation was made. Fetch next returns one update at a time. If we make multiple changes to the data at once, we want the cursor to return multiple changes. We can use fetch n instead, where n tells cursor how many updates to return. Here we've added 2 rows to the table, so we use fetch2 to see the both updates at once. Otherwise, if we use fetch next, we'll have to just run it twice to see both the updates. The cursor also returns an RW timestamp column, which tells us when the change was made. The timestamp determines the order in which the cursor will return the updates. If 2 updates have the same timestamps, the order may or may not reflect the actual chain of events if the data don't have the same primary key. So far, we've only done the insertions, but there are 4 other possible values the cursor can return in the op column. Let's see what the other 3 are. Say we have an update, say we want to make an update to an existing value in the table. Here we change the value of C3 to 10 for the row where the column C1 value is 1. If we fetch multiple updates from the cursor, this change will be reflected as an update delete, where the deleting the previous value of C3, and the update insert, where if we are inserting the new value of 10 into C3. And lastly, we have the delete operation for when we delete a row of data from the table. Previously, the values returned in the op column were integers that correspond to one of the 4 operations. In version 2.0, they've been updated to strings to make things more readable and user-friendly. That's the quick review of how to create and use subscriptions and subscription cursors in RisingWave. If you have any further questions, please check out our documentation or reach us on our community Slack for support. Thanks. All right. All right. That was the quick demo. I know this is pretty simplistic, but the power of how we've designed it is to align it with how you would run any SQL commands in terms of creating a subscription, creating a cursor. Um, in terms, if you're coming from more from a database world, you should be familiar with how to create basically how to get uh, real-time notifications using plain SQL. So let me go to the next slide to see if I have. Yeah. So that kind of finishes our demo. So I want to make sure if there are any questions that we can address at this point.
Any questions? Yeah, maybe not this time, but maybe next.
Yeah, I think you know where to reach us. We're on Slack. If you have any questions, obviously we have the documentation page on subscription. There's a dedicated page that goes into more detail, has a couple of example use cases, and also how to read from a Python program for subscriptions. There's additional information there. So feel free to check out the documentation, and then if you have any questions, you can reach us on our community Slack. Okay.
Actually, there is one question, Rayees.
Oh, is it? Okay. Let me see.
Yeah, one from Pranay. If you can
Okay.
just type in the chat.
Yeah, possible downstream systems tools for subscriptions. So yeah, the way we have seen users use their own tool systems. Like this could be any databases, for example. We have seen people write to even S3 uh, in terms of where the destination could be. So it really is not. There's no limit on what those systems could be. It's totally up to the user's requirements, so to speak. Yeah, the most common, in terms of the latency, what I've seen is Elasticsearch, because in some cases, when there is a strict latency requirement, a few customers of ours are using Elasticsearch. But again, it's totally driven by the application needs. Okay. Yeah, it seems like this is a straightforward feature, so there's not much question. So, well, yeah, we'll share the recording for others to, review at a later time. Thank you, everyone.
Thanks. See you on Friday.
Okay, bye-bye.